All right, in today's video, we're going to talk about how to complete the square. In order to understand completing the square, it's important for us to understand where those squared terms come from. So I'm going to start by having us expand the following terms. If I were to expand x plus 3 squared, that's me multiplying out x plus 3 by x plus 3. And in the process of multiplication, I end up getting x squared plus 3x plus 3x plus 9. And the middle term becomes x squared plus 6x plus 9. All right, then if I do the same thing with x minus 5, I take x minus 5 times x minus 5, I get x squared negative 5x plus 25. And that becomes x squared minus 10x plus 25. And then with the last one, if I have x plus 10, I'm going to go ahead and multiply it out, x plus 10 by x plus 10. We get x squared plus 10x plus 10x plus 100. And so that's x squared plus 20x plus 100. Okay. What our goal is that we're going to take some sort of quadratic in order to complete the square, and we're going to actually have just these first two parts of the term, right? So we're going to have something like x squared minus, 8x, and then your goal is to end up completing that square. And so what we want to do is we want to ask ourselves, where do these numbers come from? So this middle term, 6x, ended up coming from, if this term x squared plus 6x plus 9 came from the perfect square x plus 3, right, so squaring x plus 3, then the 6 came from doubling 3x, right? So I added the term 3x 2 times, and that 3 was right here in that parentheses. Okay, and I can see the same pattern here, right? The negative 5, the middle term is double. The positive 10, the middle term is double. So when I go to write my square for this, if I want to write this as a quantity squared, I take negative 8, I'm going to cut it in half. So it's going to be negative 4. Okay, and then the final term, if I think about how that relates, right, that plus 9 comes from if I had taken half of 6, right, and then I square it to get the 9. Let's see if that works here. Take half of negative 10, square it to get 25. Half of 20, square it to get 100. All right, so in this case, if I were to complete the square, if I had something like y equals x squared minus 8x, to complete that square, I'd want to write plus 16 because I would have squared negative 4. All right, now let's try this with another example from the beginning and just kind of go from the start to the finish, right? So this, I guess, was example 1. Now we're going to talk about example 2. So let's say that I take something like h of x equals, let's do x squared minus 10x plus 8. Now this one's different because the first problem that I gave you, we didn't have a third term there, right? So what we're going to do is we're going to start by saying, let's get this constant out of our way. We want to move it to the other side so that temporarily we just don't have to think about it. Okay? So now it's x squared minus 10x. And the goal here is for me to think, okay, well, what would I end up adding on this side? Well, if I'm going to make this a perfect square, to get this in the quantity squared format, I'm going to have to take x and then half of negative 10. So it's going to be x minus 5 quantity squared, which means I'm going to square that negative 5 to get this last term. So technically I'm adding 25 over here. Now if I add 25 to the right side of the equation, I can't do that without balancing it on the left-hand side. So I'm going to have to add 25 to the left-hand side. And that looks a little funny, but really I'm just combining these like terms. So the 25 and the negative 8 should get combined on the left-hand side. So on the left-hand side, I now have h of x plus what, 17 equals the quantity x minus 5 squared. And then last but not least, if I asked you to put this in vertex form, I would move that minus 17 back over. Okay? So h of x is equal to the quantity x minus 5 squared minus 17. All right, let's try another one. So let's say that I give you g of x equals, let's do negative 2x squared, minus 32x plus 7. Okay, and our goal is to complete the square to put this in vertex form. Okay, so we want to put this in vertex form. So first we're going to go ahead and move that 7 out of the way, right? So I want to get rid of that constant term because it's just kind of in my way when I think about completing the square. So I move it over. I get negative 2x squared minus 32x. Okay, now if I think about vertex form, okay, I didn't have to think about this on the last problem because it didn't exist. The a value was 1. When I think about vertex form looks like this. Y equals a times x minus h squared plus k. And notice that in the parentheses, and all the warm-up problems that I had us do as far as multiplying it out, it was a lead coefficient of 1 on x. The a was factored out. So that negative 2 that's in front of x squared right now, I'm going to actually factor that out so that I don't have to think about it when I'm completing the square. So this is going to be negative 2 times x squared. It'll be plus 16x. And then I'm going to leave a little space there so I can think, okay, what would complete that square? I didn't change the right-hand side at all as far as the quantity yet, right? So I didn't add or subtract anything. I just factored out that negative 2, so I don't have to do anything on the left-hand side. Okay, now I want to think about how would I make this into a perfect square. So negative 2 times the quantity squared. Half of 16 is 8, so it'll be x plus 8 is going to be my perfect square there. And then to finish that, I would be adding 64 over here. Okay, and now our gut instinct is to say, okay, we added 64 to the right side, so we need to add that to the left. Okay, but I'm going to caution you before you do that. Remember, this 64 is in parentheses, and it was multiplied, or will be multiplied by negative 2. So on the left-hand side, we're going to add negative 2 times 64. So this was me adding this value here. I did that on both sides, so I should be good. And then the negative 2 times x plus 8 squared is just me rewriting x squared plus 16x plus 64 times the negative 2. And then I'm going to combine like terms here. G of x, negative 2 times 64 is negative 128. Negative 128 and negative 7 makes negative 135. And then last but not least, I want to put this in vertex form, so I'm going to move that 135 over. So it's g of x equals negative 2 times x plus 8 squared plus 135. Okay, I have some time. I'll go through one more example just so that you kind of have this in the bag. You can feel free to stop the video and see if you can guess what's next as you go. Let's try completing the square to put y equals, let's do y plus 4 equals 3x squared minus 12x plus 9. We're going to put this in vertex form. Okay, and just like the problems before, we're going to start by saying, wait a second, this constant's kind of in my way. I don't want it there. So we're going to subtract 9 from both sides. So I get y minus 5 equals 3x squared minus 12x. And then I have to go ahead and factor out that a value. So I'm going to rewrite this as y minus 5 equals 3 times x squared minus 4x. And I'm going to leave a little space to ask myself, what would I end up adding there? If I rewrite this as the quantity x minus something squared, I'm going to have to take that minus 4 and cut it in half. So it's going to be the quantity x minus 2 squared. And then take that negative 2 to figure out, well, what would this have been? This would have been plus 4, because I would have squared negative 2 to get plus 4. And now keeping in mind, on the right-hand side, I actually added 3 times 4, that quantity. That was new. It wasn't there before. So then on the left-hand side, y minus 5 plus the quantity 3 times 4. And then I'm going to clean this up a little bit. Negative 5 plus 12 is positive 7. And then move this into vertex form by subtracting the 7 to the other side. And then we're done. Okay, I hope that helped as far as completing the square goes. The next video is on the derivation of the equation for the vertex from standard form, and also the derivation of the quadratic formula.